Is your child watering down your vodka when you're not looking? We have the scientific tool for you, the refractometer. Cheap, accessible, and easy to use. The refractometer. Today, we're going over the handheld refractometer experiment taught by Dr. Gruber for Chem 400, presented by yours truly, Max. For our experiment, we tested several substances using the refractometer. A few of the substances we tested is lemon lime, rice seasoning, coffee, cabbage, lemon juice, soy sauce, Gatorade, dyed Mountain Dew, pickle J, or pickle juice, and fish sauce. We noticed that solutions with more salts and sugars tended to have higher indexes of refraction. In addition, seasonings like soy sauce, rice seasoning, and fish sauce could not be read by the refractometer. This may be due to the high concentrations of salts and proteins. This has an increased probability of scattering the light in many directions, therefore leading to us not being able to measure it properly. The refractometer uses a physical phenomena called light refraction. When light passes through any medium, there is a natural angle at which the light bends. We can use this phenomena to figure out what medium the material is based on its refractive index. As you can see, the refractometer is made of several components. It has a lid you can open to put your sample. The illuminator flap with the matted surface is where the sample will go. When you look through the eyepiece, the measuring prism will reflect back onto the shadow boundary and its graduation. This will tell you its refractive index. A few of the parts of the refractometer is the calibration screw, the bimetallic strip, a scale on the inside, the measuring prism, and of course, the light source. Our next experiment was analyzing the refractive index of salt solutions. As you can see, the more mass of NaCl we added to our water solution, the higher our measurement on our refractometer. The data collected, for the most part, was linear, with slight deviation. Our third experiment involved studying the refractive index of hot chocolate. Here, we had a more linear relationship for hot chocolate. A big problem with measuring the hot chocolate. A big problem when measuring the was mixing the solution evenly into the 10 millimeters of water. As we increased the mass of the solution, it just got real clumpy, Like that wasn't enough water for it to spread evenly. So if you're doing this experiment and you choose a substance that like doesn't like spread out evenly, you're gonna be in a little bit of trouble. Because when I was doing it, I had higher concentrations in some places, and I really had to mix it in. But even still, it was a little bit of a mess. So I'd recommend doing something more what's the word, like soluble. I don't think that's the right context if it's a mixture, but you know what I mean. It has to be able to mix evenly for you to get the best data. So that was a big problem when using hot chocolate. Conclusion: I just remembered I never told you why a refractometer is good for seeing if your kids stole your vodka. Well, obviously, we could take a sample of that vodka and compare it with an original sample of whatever vodka you like, Smirnoff, something like that. And then you could compare those two results. If you have a lower refractive index that's closer to water, being like 0.333, something like that, hot chocolate, your kids stole your vodka, and they should be punished. So, in conclusion, the refractometer is a great tool to validate which substances you are working with. What else? The results from my experiment gave me a new appreciation for the phenomena of the universe, how light works, how we could just know what something is based on how much the light will bend. That's pretty cool. My data kind of sucked a little bit, there's like a little bit of variation, but it was mostly linear. I fudged the numbers a tiny bit, but not too much. But, the results were mostly what I expected. Adding more of the substance would lead to a higher refractive index, because as we, add more material, the light is scattering through less water and more of that particular substance. So that was very fascinating. I forgot to talk about we talked about it briefly, but I forgot to talk about the soy sauce and the fish sauce and stuff. That's interesting. Like when I first saw all those three things, I was just like, MSG. Is it is it because there's like MSG in there? I don't know. But definitely a higher concentration of salt and proteins or whatever will definitely change that. Um, what was interesting though was as I kept adding more salt, it the refractometer eventually started getting to the scale to where if I put way too much, it was going to go way past that. So I definitely think the reason why we weren't able to read, some of the other like household items like the soy sauce and stuff, is because of that high salt index. So so yeah, that's refractometer, everybody. Hope you enjoyed.